out to be 300. Obviously 300 is less than 960, so condition is getting satisfied. Now for the second horizontal row, we have Rn plus 1, that is the demand of the third month, which is 20. So 2 square, that is 4 into 20, which gives you 80. Still 80 is less than 960, so condition is getting satisfied. Now for third one, it is what we need is fourth month demand, which was 140. So when you take 140 into 9, it gives you 1260. That condition n square Rn plus 1. And obviously 1260 is greater than 960. So I will have to change the group here. Also one thing more that will come as a fourth slide. So if you sum up this Ri, this is first group, which says total demand in the first group is of 520 units, 200 plus 300 plus 20. So total 520 units. And now because this condition is failing, in the fourth month I will have to start once again with n is equal to 1. Let's have it here. So we are with the fourth month. Demand for the fourth month was given to be 140, and now n is equal to 1. And for the next month, that is for the fifth month, it is 180 units. So 1 square into 180, which is 180, which is less than 960. So condition is getting satisfied. So I can continue with n is equal to 2. That is, I have to increase n by 1. So n is equal to 2. Find out the condition, which is 1440. Obviously 1440 is greater than 960. So I have to stop this group. And for the sixth month, once again I will have to start with n is equal to 1. And for this group, total demand is of 320 units. For the first group, it is 520 units. For second group, it is 320 units. Then for the third group, similar to previous procedure, we have first time for 6th month condition is getting satisfied. For 7th month, again condition is getting satisfied. For 8th month, condition is failing. So for 9th month, we'll have to start with n is equal to 1. Okay. And only demand of 10th month is given. So here 270 into 1 square. So it will turn out to be 270. But for 11, no doubt condition is getting satisfied because 270 is less than 960. But I can't carry out the same step because in next one I don't have demand of the 11th month. So here group will be of 9th and 10th month, which is 570 units. So what we have in all, we have 4 setups with their sizes 520 units, 320 units, 756 units and 370 units. So in all 4 setups are required to optimize the total cost. But obviously quite crude method, because no doubt we can say that it is crude method when it is to be done manually. But when you can, if you are master in Excel or C++, you can have a loop and make a groupism. So you can, and wherever this condition is not getting satisfied, that is n square Rn plus 1 is less than a by h, this condition is not getting satisfied, just exit out of the loop and find out what is the total demand for that particular group, and you can sum it up. Okay, till now what we had unit cost to be constant. But as you know, this whatever season is going on of sales, wherever you go, you will find sell season going on, or you will be getting lots of messages for this sales. Okay, so let's have how to work with such sell system. So we'll have problems of EOQ, that is how to order procurement quantity when there are price breaks. Often discounts are offered for the prices for the purchase of large quantities. So what we have in Pantaloon, just buy 2 you will be getting in this much, and buy 3 you will be getting in 399. So that is what it says. If you purchase more number of units, you will be getting it at a lesser price. So this discount takes the form of price breaks. Let us consider a vendor who is encountered with a problem of determining optimal purchase quantity for each order. The assumptions are demand once again a constant and uniform. No doubt this is once again very ideal situation, because when there is a sale, and you people must have observed, when there is a sale there is a rush. Okay, so demand may not be a constant in that case, and obviously when it is not constant, even it is not uniform, because at the end of the week demand will be the maximum. Most of the people will go to Pantaloons, V-Mart, Big Bazaar, particularly on Saturday and Sunday weekends. Okay, shortages are not allowed, and replenishment of items is instantaneous. Here shortages are not allowed is taken with some purpose, because when there is a sale season and if there is a shortage, then there will be a halagulla at the exit of the shop, okay, or exit of the mall, and that management will not like. So let's have a Q to be lot size as usual, R to be demand, and all units are always there. Just we have given the symbols. A is ordering cost, CI purchase cost per unit for ith price break, I is the holding cost rate per unit per year. So if you find for the first purchase cost, say C1 is the first purchase cost, total cost will turn out to be C1R, this is purchase of whatever demand was, that is C1R, plus AR by Q, that is ordering cost per unit per time unit, and half C1 IQ. So first one is purchase cost, second one is ordering cost, and third one is inventory holding cost. In this case, whenever there is a price discount or price escalation, one has to consider the third cost, which is purchase cost, because it plays a vital role in optimizing the total cost. For the optimal order quantity Q star, say, that gives the minimum annual cost K, we have derivative of K with respect to Q to be 0. That is what we were following. And second order should be greater than 0, because we said we want to our aim was to minimize the total cost.
By using these conditions, we can obtain the optimal order quantity, that is nothing but your Q star, which is square root of 2AR upon C1I, and the total cost of an inventory system, which is turns out to be square root of 2AR C1I. This graph represents the price break graph, which is order quantity versus total inventory cost.
Here B1, B2, B3 in the graph are the price breaks, that is for 100 units, 200 units, 300 units, and so on. And the solid region of the curve, which is on the slide, represents the total cost in that particular region. So the first curve, if you look at, that is the uppermost, will be having a higher cost, that is higher purchase cost. Then second one will be C2, which is smaller, then C3 and C4. So in this case, when there is a price break, what we assume that C1 greater than C2, greater than C3, greater than C4, and so on, and you can continue with number of price breaks.
So now we are considering the problem of EOQ with one price break. That means if we are given only one price break over there, that is nothing but say B10 in this case. That means if you are going to have the number of ordered quantity to be greater than B1, that means you are paying purchase price to be C2, and if you are having that ordered quantity to be less than B1, then you are paying a purchase price C1 over there. In fact, C2 must be less than C1, we know that, because we are getting discounts over there. So the EOQ can be computed by using the following algorithm. First of all, start with the getting we are assuming that we must have the maximum profit in that case. So we'll proceed with the starting with the Q2, optimal value of Q2 over there. That means we are using the second purchase price, that is C2, and then from that we will use our usual EOQ model, and we will get the optimal value of Q2O. If the value of Q2O is larger than B1, so we can go for the second break over there, and from that we can have the optimal value of Q2O, that is to be as our optimal value for the system. But if the value of Q2O is less than B1, that means it is falls in the first break over there, then we need to use the purchase price in place of C2, we need to use the C1 over there, and then after find out the optimal Q1 value over there. Then this optimal Q1 must be compared with the value of B1. If the value of B1 is find out the total cost for the B1 as well as find out the total cost of Q1O, and if whatever the smaller one is there, we need to go for that. Okay, that means if the cost of Q1O is smaller than cost of B1, then we need to find we need to go for Q1 ordering Q1 order over there.
Let's see by this example how one price break works. What question says, if you order for 500 units, then it will cost you 10 rupees, and if it is more, if your order is of more than 500 units, it will save you 75 paisa. That is, total purchase cost will turn out to be 9.25. Okay. The monthly demand of the product is 200 units, and the cost of storage is 2% of the unit cost, and the cost of ordering is 350 rupees. So we are given A to be 350, R to be 200, I to be 0.02. First price break is at 10 rupees, and second one at 9.25. As Professor Kunal said, we have to start with the highest discount. So I will have to start with 9.25, which is the highest discount available. Find out Q2 using this 9.25, and it gives you 870 units. That is, procure 870 units at 9.25 rupees as a purchase cost. But if you look at the price break, we had price break at 500 units, which says that Q2 is greater than 500 units. So optimal purchase quantity is 870 units, and that will give you the minimum cost at discounted price 9.25 units. Okay. If the let's see how to compute this discount. Suppose a company has 8,000 units, and which is costing it to be 10 rupees per unit, and ordering cost per purchase is rupees 40, and holding cost is 28% of the average. And what condition given was, if it is offered quantity discount of 1%, if it purchases its entire requirement only 4 times a year. So number of orders is fixed. Should the company accept the offer of quantity discount of 1%? If not, what minimum discount should the company demand? Using similar approach what we had for one price break, it says Q is 478, and total cost corresponding to 478 turns out to be 81,338 rupees 0.66 paisa when discount is not available. But when discount is available, it gives 2,000 units, and total cost turns out to be 82,132. So obviously this is somewhat higher. So 1% discount is offered. So company should not accept the offer of 1% discount. And we want to give an option of, say, how much discount can be available. Start with X%, and this X% should be compared with the when discount is not available. It says if company is offered 2% discount, it is advantageous and it is to be accepted.
Grocery નો example આપો.
નહીં અપાય, ટાઈમ થઈ ગયો છે. ઓકે,
5 મિનિટ.
થેન્ક યુ. નથી અપાય, ટાઈમ થઈ
મેં
ગયો.
કીધું ને 5 મિનિટ છે.
થઈ ગયું છે, ક્યારનું કીધું.